All right, so this is the final project for Big Data Analytics Spring 2021, visualizing big data with Plotly Dash apps. So the problem statement for this project is what happened with graduate school interest over the COVID-19? Did it become more popular or did it become less popular? We can build a dashboard with Plotly's Dash framework to answer this question. So to get started, we need to pull down our data sources, consider what visualizations we want to use, research Plotly's Dash framework to understand how to integrate those visualizations, build the dashboard, and launch the dashboard. The technology used to building this dashboard is Python, Plotly's Dash framework, scikit-learn, and Google Trends API, and Spark. So there are some instructions here with pip to install these packages with Python. So Dash applications are open source. They can be very customized and personalized with Python, R, or Julia. You can utilize plotly.js graphing library with the language of your choice. They are built within the code using two primary components, and those are called the layout and the app callback, and that's very important to how to structure the code, and we'll get into that. So Dash comes with an HTML library and component library to be able to build that layout and app callback. So the competitors are Shiny, Tableau, Looker, and other BI tools. So let's talk about data and preparation. So the data sets for this project are the Google Trends API, which pulls down search popularity based on keywords. So it will return a number between 0 and 100, indicating how popular that search term is in a given time period. So the Grad Cafe data, it reflects applicant data, and so we'll use that to determine the trends in applicants over time. The data sets were imported and manipulated with two Python files that have custom Python classes inside of them. So those are the extract classes and the transform classes, and inside of those you'll find extract trends, extract SV, and quality check and Spark transform, which will help to manipulate these data sets. The transform classes are using Spark to transform the data. So the data sets go in as pandas data frames and are manipulated with Spark using the Spark SQL API and Spark Data Frame API. So to determine visualizations, we can use the Plotly Python open source graphing library, which has a ton of different graphs in there that are available for use and instructions on how to integrate them into your dashboard. So for this project, the dashboard has box plots, feature importance, and time series charts. So to build the dashboard, we need to first look over here in the top right at this gray box, which is the file layout. So this dashboard in particular is a multi-tab app. Not every app needs to be multi-tab. In fact, you can have one file and launch that as your dashboard. But if you want to implement multiple tabs for your dashboard, then you need to have this file structure over here in the right. You need to have an app.py file, which will initialize your app by creating an app variable. And here we can see right here the entire contents of the app file, so it's not very much. And then you need to have an index.py file, which is basically your home app. And of course, in all of your apps, other than the app.py file, you need to have all of the important libraries included with Dash to pull in to be able to create your layout and your app callback. And those libraries are Dash core components, which are aliased as DCC, Dash HTML components, which are HTML, aliased as HTML, and the Dash dependencies need to also be imported, which help with the callbacks, pulling in input and output functions. So we also can create a file to pull in our data neatly and cleanly, and so that's what's over here is pulldata.py. So optionally, you can create a file to also house your data manipulations and transformations. So let's talk about the Dash libraries before getting into the build of the dashboard. So these two libraries, Dash HTML components and Dash core components, are very important to building the layout of the app. And the layout is the first part of the code structure, whereas the app callback is the second structure. So HTML div is one of the methods that you can use, and this allows you, and this from the HTML components library, and this will allow you to divide up the layout. So you can nest these and you can have as many as you want, dividing up the different parts of your layout. And so you can also include HTML header, which is the same as below. HTML H1, 2, 3, and 4 are also different variants in sizing of the headers. HTMLP will allow you to have paragraph style text, so just regular sized text for writing. The Dash core components is really what creates the interactive component of the app. So here's some examples of the core component methods and functions that you can pull down. So you have the drop down, radio button, and graph. And so here, the drop down, you can see below how this little drop down here was just generated with the Dash core components DCC drop down. And the radio buttons down here with these little bubbles were generated with DCC radio button. And DCC graph, although there is not a graph here, this is all it is it has one, it's just a function, and it will intake a figure which is pushed from the app callback, which we will get into. You can also see here that there are two different variants of a header and a paragraph style text here. So all of that is being generated by these libraries that come built with Dash and make it very easy to implement these different features to your dashboard. So to build the Dash, let's start with the home app. So I've mentioned that there is a layout, and let's look over here, that's what this is, and the app callback over here in the bottom right. And so the HTML div is dividing up this layout, and inside we have nested a number of different combinations of the core components and the HTML functions. And so that's what you'll see normally is a combination of these components and HTML to include HTML and those interactive features. So what's important to know here is that in the app callback, it's intaking, has an input function and output function, which intakes these IDs. And these IDs are coming straight from the layout. So up here you see the ID equals URL, and that is what is being input here to this app callback. The output is tab content, which is not pictured here, but is another ID inside of the HTML div for the layout. Over here, inside of the app callback, we have a simple function, and all this is, it takes in the value of the input, and it outputs, like any other function based on some conditions, to the output. So let's visualize the home app, and here you can see that there is a header, there is a subheader, and some paragraph style text. And up top here you can also see that there's some more text, and here are the tabs that define the overall model or overall dashboard. So to build the dashboard features app, we can create another file inside of the apps folder, which was named features.py. And again, we have this layouts, the layout defined, and we have the app callback defined. And over here we can see some of those familiar functions, the H3, H4 for header styling, paragraph, drop down radio items, and here we see DCC graph, an instance of that. All it is it's intaking an ID. So over here we can look at the app callback, and this is the full app callback for generating a box plot, and we can see it intakes a y-axis and x-axis, which are coming from the IDs in the layout over here, generated by ID y-axis from the radio items, and x-axis being generated from the ID for the dropdown. So when values are selected in the dropdown and values are selected in the radio items, those are passed to the app callback. And what happens inside the app callback is defined by the function, which intakes those inputs and passes them to a function and outputs a figure to send to this ID, boxplot, which you can see aligns with DCC graph for ID boxplot. So visualizing the features app shows you the different box plots that were generated. You can hover over the different areas of the box plots to get interactive features. And over here, there is a time series chart, which is defined later on in the features app. So building the models app, so this is our third and final tab to build. We have, again, the layout and the app callback. So within the layout, we have, again, these familiar HTML div, HTML H3, breaking up the layout and putting a header, putting another header, but a smaller one, putting a paragraph, just regular text in there, and defining a radio item, and defining a graph. So this is defining the features importance graph. So inside of the app callback, we need to push the right figure to the graph to get this to work. So we have the input of model one, name one, which is coming from the radio items, which is just regression at this time. And the output is COVID, which sends it to, let's not get confused with the header up here, to the ID for the graph. So inside of the function, it's intaking that model name, sending it to the function and fitting a linear regression model, and returning a figure, which is a feature importance chart. So to visualize the models app, we can see that these are the feature importance charts, and again, we have headers and two feature importance charts within the full code. So some insights found from this project are that graduate school searches seem to have more of a positive relationship with bootcamp, financial aid, Glassdoor, job search, keywords, and also online classes, professional development, recommendation letter, keywords. So then grad school searches seemed to be less popular when compared to COVID, stimulus check, and remote work keywords. And so this is based on the medians of the box plots. The feature importance chart showed that COVID was the most important feature, followed by professional development, online classes, and remote work based on that linear regression model fit. The time series chart showed that applicants really peaked in 2014, and 2020 actually saw a low around 2011. And so that's plotting the notification when applicants are notified for their application to graduate school. So it does make sense that there are certain peaks, but it also shows the volume of applicants as well. So we saw that 2020 was particularly low. So to launch the dashboard, we can go ahead and in your terminal or Windows PowerShell, type the appropriate commands, Python 3 index.py for Mac OS, and you would want to visit localhost 8050. Remember to be in the directory of index.py after pulling down the project files. So when we launch the app, we can see that we see the home page here that was built. We see the models tab, which gives us the feature importance chart, which if we hover over, we can see COVID is the most strongest feature here, and we can hover over it to be able to see the different information inside. We can also click on Analyze Features and see the box plots that were built with the drop downs. So we can click through and see the different graphs that are created, and we can also toggle between the log of graduate school and graduate school, which is very nifty. Down here we can see a post-COVID chart to see 2019 through the current data versus 2019 through 2021, so limited. Down here at the bottom, we can see data from 2006 to current, and what this is showing us is the peaks and times when applicants are notified, and also showing us the general volume of applicants. And all of these graphs can be downloaded as a plot, a PNG plot. You can zoom in on it. You can expand or pan out, but let's zoom in with these buttons here. So you can actually show, you can play around with these and click and see the different options. So some of the lessons learned from this project: to update as you edit the dashboard, capable of implementing real-time updates for streaming data. Plotly, use the Plotly graphing library, which is really helpful, and it's a free BI tool. Some of the cons are that Spark can only be fully integrated with the Dash Enterprise account. Unfortunately, there's a lot of upfront work involved. You need to understand really well one of the programming languages Dash offers the builds with, and generally good lessons would be to start building one app at a time and integrate them into a multi-tab application after you have several of them. Many additional ML graphs would be interesting to explore that were not aligned with this project but look very promising, and the PyTrends package for the Google Trends API is not particularly mature and is difficult to work with. So that is the project for building dashboards with Plotly's Dash framework.